Welcome to this online course provided by the Boosting Project on managing risk in circular water systems. This is Module 2, Risk Assessment Tools and Frameworks, and this is the first unit. We will look at safety plans for water reuse. By the end of this unit, you will be able to explain what a water reuse safety plan is and why it matters, to identify the key components and practical steps that make up such a plan, and to recognize how these plans help manage risks across the entire reuse circle, ensuring safe, sustainable, and trusted water reuse. As it has been explained in previous modules, water reuse has gained significant attention in recent years as a smart and sustainable response to water scarcity. It reduces pressure on freshwater supplies and supports resource recovery. But for reuse to succeed, it must also be safe. Protecting public health and the environment is essential, and this is where safety plans come in. A water reuse safety plan is a structured, proactive tool to identify hazards, assess risks, and put control measures in place to prevent harm. These plans build on internationally recognized frameworks, such as the World Health Organization and the International Water Association Water Safety Plans approach, and they are always tailored to the specific context of each reuse system. They are also embedded in regulation. For example, in Europe, the recent EU regulation on minimum requirements for water reuse makes risk management plans mandatory for agricultural applications, with detailed guidance provided by the Joint Research Center. In the United States, the Environmental Protection Agency's National Water Reuse Action Plan promotes safe reuse through collaborative policies and partnerships. Let's now explore the key components of a water reuse safety plan. Each step plays a critical role in ensuring that the reclaimed water is used safely and effectively. We begin with the system description. This outlines the entire reuse chain, from the source through treatment and finally to the intended use application. Next is hazard identification. Here we pinpoint potential hazards such as pathogens, heavy metals, or contaminants of emerging concern that could enter the reuse system. If not controlled, these hazards can lead to events like contamination of crops, risks to workers or consumers, or harm to the environment. Once hazards are identified, we move to the risk assessment. This step evaluates how likely each hazard is to occur and how serious the consequences will be. Often, this is visualized using a likelihood versus impact matrix, which we will explore in more detail in a later video. The next step is defining control measures, the physical or operational barriers that reduce or eliminate risks. These can include treatment steps or real-time monitoring technologies. But having controls measures isn't enough. We also need verification and validation. This means sampling, testing, and inspections to confirm the system is working as intended and risks remain under control. To make everything systematic, management procedures are put in place. This includes standard operating procedures for normal operation and contingency plans to guide responses if something goes wrong. Finally, a critical component is stakeholder involvement and risk communication. Farmers, industries, regulators, and even the public all play a role. Their feedback is essential, not only in reporting possible risks and how they are perceived, but also in refining the assessment of likelihoods and impacts throughout the safety plan. Let's bring everything together with a practical example. Imagine a municipality that wants to reuse treated wastewater for agricultural irrigation. The first step is to map the system. The water originates from a municipal wastewater treatment plant, passes through treatment processes, including disinfection, and is then delivered to local farmers for irrigation. Next, we identify hazards. Common risks include microbial pathogens, residual nutrients, and trace chemicals that may remain after treatment. Then comes the risk assessment. For example, there may be exposure to pathogens during manual irrigation or through direct crop contact. Then we estimate both the likelihood of these hazards and the severity of their impact. Once risks are assessed, we apply controls measures. The municipality installs advanced disinfection systems and applies irrigation scheduling rules to reduce exposure. Verification and validation are also essential. Regular water sampling and checklists confirm that the system is working as planned. Finally, stakeholders play a key role. Local farmers and regulators are trained in safe practices and receive clear communication about risks, controls, and monitoring results. This example shows how safety plans work in practice, providing a structured way to make water reuse safe, transparent, and trusted. What benefits and challenges arise when putting a safety plan into practice? On the benefits side, there are several clear advantages. First, safety plans reduce risks to both human health and the environment by identifying hazards and applying the right controls. They also ensure compliance with regulations such as the EU Water Reuse Regulation. Safety plans build confidence and trust among farmers, consumers, and regulators. They promote resource efficiency, and finally, they support public acceptance and even market access. But of course, there are also challenges. Sometimes there are data gaps which make risk assessment difficult. Operational and technical limitations can also pose barriers. Coordination among multiple stakeholders is critical but not always easy to achieve. Risk is not static. Weather events, usage changes, or system shocks require ongoing dynamic risk assessment. And in many cases, fragmented or overlapping legislation creates confusion and slows down implementation. By understanding both the benefits and the challenges, we can make more informed, practical, and realistic decisions when planning safe water reuse projects. To wrap up, here are the main takeaways from this unit. In the next unit, we will discuss how to use risk matrices, looking at likelihood versus impact to assess and prioritize risks in reuse systems. Thank you for watching.